Welcome back, my dear students, to physics online classes. As lockdown is going on, we are going to continue our classes online. My humble request is, please stay home, stay safe, love your family, care yourself, care your family, and live healthy. So let us continue with the topic. So our last topic was, what is spectrum? And there we have even learned what is electromagnetic spectrum. And now today in detail we are going to learn about what is electromagnetic spectrum. So we have learned about wavelength. Wavelength is nothing but it is denoted by lambda. Okay, it is denoted by lambda. And frequency is denoted by nu. Okay. So there is no confusion, I hope. Now, the relationship between the lambda and nu is C is equal to nu lambda. Okay. Now, what is electromagnetic spectrum? Electromagnetic spectrum is nothing but it is having a variety of frequency. Right, it is having a variety of frequency. The entire range of electromagnetic waves frequency is called as electromagnetic spectrum. As we go to like check post and all, there we can see that there is a limit for everything. For to cross one lane, you have some limit. To pass from there again, you have one more limit. From there again one more limit. So we have different lanes, like divisions we have, right? Yeah, exactly. So similarly, when you go to the electromagnetic spectrum, you have there different segments, like different divisions there you can find out. What are those? They are divided into 7 types. They are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. Okay, you can easily remember it. There is no confusion. Radio, micro, infrared, visible light, ultraviolet, X-ray and gamma rays. Okay, now you can see that there is more wavelength. Okay, and here you are having less frequency. Here you can see that there is less wavelength and you have very high frequency. So with this we can say that whenever there is increase in the wavelength, you will find a decrease in the frequency. Whenever there is increase in the frequency, there is a decrease in the wavelength. Okay, so whatever we are able to see, the Vibgyor color, yesterday in my last video I have talked about the rainbow. Whatever Vibgyor colors we are able to see in the rainbow, they are nothing but they are available in our visible light. Whatever colors we are able to see, they are observed in the visible region. That's why they are called as Vibgyor. Okay, and the rest we are not able to see them. So where are these radio waves used? These radio waves are used in the broadcasting, like televisions, the radio stations. Okay, wherever we are able to listen, like they are far away from us, but still we are able to listen. How? Because of these radio waves. The rays coming out of your mobiles, all these are nothing but the radio waves. They may affect you. That's why we ask you to use the mobiles and all less. Okay, and next coming to the microwaves, they are usually used in the cooking purposes. Like in our house we have stoves, induction stoves and microwave ovens, etc. Right? There we use in this waves. IR, they are using the radiators, they are using the signals, etc. And visible light, whatever light we can see, that is nothing but the visible light. UV rays are nothing but you can see that they are absorbed by our skin and it may damage our skin. And they are used in the fluorescence. Okay, fluorescent tubes they are used. Then X-rays, we obviously know what are X-rays. As we see, whatever we go in our medicinal use, like whenever we get hurt, we get X-ray done. Okay, through which we can observe our bone damage and all. And gamma rays, this is very important, children. You have to know that gamma rays, where the gamma rays is used. Gamma rays is used in the cancer treatment. Yes, children, it is used in the cancer treatment. Now, we even have to remember the wavelengths of these electromagnetic spectrum, and remaining rest, you can see that only the visible region we can see the rays. Okay, rest of it, they are not visible to us, right? Next, coming to the part how you can remember the wavelengths of these different spectrums. Yes, you can see here that as I've already explained you, as the frequency increases, the wavelength decreases. As the wavelength decreases, the frequency increases. So now you can see that first you go with the visible light. First you go with the visible light. There you write 700 nanometers to 400 nanometers. Right. From there, you just come down, decrease it. 400 nanometers to 1 nanometer. And then again you come from 1 nanometer to 10 to the power of minus 3 nanometer. Then again less than 10 to the power 3 minus 3 nanometer. Then here you go up 700 nanometer from where? From 1 mm. Then again from 1 till 1 mm. From where? 0.1 mm. Then again above you can write it as greater than 0.1. Okay, 0.1 meters. Then next, coming to the next topic, that is your Planck's constant. Okay, who was Max Planck? Max Planck was a famous scientist who gave us the clear definition of energy, electrons, photons. Okay, photons are nothing but the light. Photon is nothing but light, as we have already know. What he said that the energy travels in a straight line or in a discontinuous way, continuous or discrete way. Okay, discrete means step by step or in a divisible part or some parts. Okay, then he said, for example, I'll tell you, you are getting some different kinds of rays. Okay, you are getting different kinds of rays. It is coming continuously, but whatever energy you are receiving, you are getting in a small packets. Okay, small energy packets you are receiving. These energy packets, this one energy packet is called this one is called as the energy packet, that is called as the photon. Okay, it is called as photon. This photon is nothing but it is light. So this light, energy of light is given as E. E is now proportional to what? E is proportional to frequency. Whatever frequency you are getting, that is nothing but proportional to E. So E, when we are removing this proportionality constant, we will write it as E is equal to h nu. Okay, we are writing it as E is equal to h nu. Now, h is nothing but Planck's constant. Obviously, because it was described by the Max Planck scientist, professor, so it is given as Planck's constant. Then, E is equal to h nu. Then what we are doing, as we already know that C is equal to nu lambda, then nu is equal to C by lambda. So what we are doing now, we are substituting the value of nu in this equation. Then E is equal to hc by lambda. Right? I hope you all have understood till here. We can write the Planck's constant value as So the value of h can be written as h is equal to 6.626 into 10 to the power minus 34 joules per joule second. Okay, we can write the value as 6.625 into 10 to the power minus 34 joules second. Okay, so what did we come to know? We came to know that Planck's constant, Max Planck explained that electromagnetic energy can be gained or lost in discrete values but not in the continuous manner. Okay, and scientists also found that each element emits its own characteristic color. These colors correspond to certain discrete wavelength. Like I already said to you, like we have one limit to move till one lane, then again from there we have one more limit, like that. Okay, एक different limits है, ठीक है. इस एक लिमिट को हम लोग लाइन स्पेक्ट्रम बोलते, ठीक है. दिस लाइन्स, दिस डिफरेंस वन, लाइक वी आर क्रॉसिंग फ्रॉम one line to another. Okay, this one line, you are moving from one point to another point. This point is nothing but, this line is nothing but, it is called as line spectra. From here again we are moving till here, this is one line spectra. Like that we have 7 line spectrums. Okay, then the line in atomic spectra can be used in identifying the elements of an atom. Okay, the elements of an atom can be known. The elements of the atom can be known by this line spectra. How? When this element will emit some color, okay, then we can say that, okay, this is this element. When this is falling in one line spectra, then we can tell, okay, this is the element which is showing this spectrum. Okay, so similarly, like we use our fingerprints to know the person. Yes, when some criminal does a crime, how we will know? By knowing the fingerprints, finding out, identifying the person. Similarly, with this line spectrum, we will come to know this element, the atom is having which element. Okay, fine. I hope you all have understood the topic, today's topic, and wait for my next video. Until then, take care of yourself, your family. Okay, bye.